Hey folks, today we're going to be talking about GitOps and application level policies that you can apply at scale and across multiple clusters. And what's better, we're going to teach you how to do it out of the box. So you and your team are using Kubernetes as part of your microservices strategy and architecture. And you now want to use GitOps. So you manage everything from Git. But as you onboard new developers, applications, services, and as you start scaling across multiple clusters, the question is, how can you define policies in an easy and scalable way across multiple clusters, and everything can be managed directly from Git? And that's what we're going to be covering today. But before we jump into the demo, let's see some of the background on the topics that we're going to be talking about. So as part of this video today, we're going to be talking about defining policies in an easy English format and scalable way, right? We're going to be defining different policies where we're going to drive different requirements across resource limits, network policy, container registry controls, and others. And the architecture we're going to be using is starting with Git. Ta-da! GitOps, right? GitOps. So we're going to have a folder there called policies, for example. And within that folder, I'm going to have three different categories: development, staging, and production. And for each, I'm going to have different policies. You may think about it as different environments, or if you want to just structure it in a different way in your environment, you may think about as project 1, 2, and 3, or teams 1, 2, and 3. So you can define the policies any way you want. And what we're going to have is we're going to have what I call a control cluster. The control cluster I'm going to be hosting on GKE, I believe. And I'm going to have one Argo. Argo is going to be watching my repo for changes to those definitions, to my policies definitions. And it's going to be working with Crossplane and Shipa to then apply these policies across multiple clusters. So we're going to be doing some multi-cluster stuff here, which is another option for you to learn on how to deal with multi-cluster scenarios for GitOps. But what's going to happen is Crossplane is going to take care of the resource sync, right? Just to make sure that whatever Argo passes on or whatever is in Git is also defined and applied to your cluster. And Shipa is going to bring the application layer. So that English readable format for you to define your application, your policies for your applications, and apply them across multiple clusters. And when I talk about multiple clusters, I have what I call two app clusters. I have one in AKS and I have another one in GKE. You could have any cluster, on-premises, Rancher, whatever you have. And these different Shipa is going to be applying my policies to these two different clusters. For each policy, the way I have broken it down for the demo today is I'm going to have development and staging policies being connected or applied to my AKS cluster. And I have my production policy applied or connected, bound, whatever you want to call it, to my GKE cluster. So one thing to keep in mind is Shipa treats these policies or policy frameworks, and as it applies to your cluster, Shipa treats it as a different namespace. So down the road, when your developers, they deploy applications, they just point their applications to a policy. They don't know if their applications are going to be deployed to GKE, AKS, 119, 121, or whatever you choose, which is great for you as a DevOps or platform engineer because it allows you to change the infrastructure under the hood and your developers won't be impacted, right? And last but not least, we're going to see a centralized dashboard where we can have observability over the policies that are being created, the details, the applications that we have within each policy, as well as we can use event webhooks to basically integrate these policies through Shipa to our incident management tools, such as Slack, Teams, PagerDuty, or whatever you use, right? We're going to start by creating our control cluster. So let's go into GKE, install Argo, Crossplane, and Shipa. All right, so starting by our control cluster, we're going to be installing ArgoCD, Crossplane, and Shipa, right? I have my two clusters here. I have one cluster called control cluster, which is the one we're going to be using, and an app cluster. If I just go into this one here, I can just click on connect. Google is going to give me the information. I can connect to it. Let me make this larger so it's easier to see. I hope this is good enough. So if I do kubectl get nodes, for example, I can see my node in there. So let's get started. I'm gonna be following the documentation to install first Crossplane under learn.shipa.io. If you go in, under Crossplane, you have Shipa provider install. I'm gonna be following pretty much the instructions here. As a heads up, if you don't have yet an account, as mentioned in the control plane or control cluster, we're gonna have ArgoCD, Crossplane, and Shipa. If you don't have a Shipa account, you can create one under apps.shipa.cloud. Again, it's apps.shipa.cloud. You can create a free account, so you can do everything we're doing here without any cost. So let's see. I'm gonna start by creating my kubectl my namespace for Crossplane. Let me make this bigger. There you go. And let me get out of the way. There you go. Done. Much better, right? Make this. All right. I create the namespace. I already have my Crossplane Helm repo added. I just refreshed it. I just updated that a few minutes ago. So I'll just go ahead and install Crossplane. Just to make it clear, on the control cluster, I have nothing installed. And it will be the same scenario for my app clusters, right? If I just do get namespace, for example, you're gonna see that I only have the Crossplane namespace, which is the one we just created. And if I do get pods, for example, I see the two pods for Crossplane initializing just now. It should take only a few seconds, I believe. There you go. Both pods are running. Now, as we move further down the document, the next part is to install the Shipa provider, right? I already have this file here installed. Not installed. I have this file created. Yes. And if I see here, I have the Shipa provider being installed in this case. So let's just apply this file. If you're starting a brand new, you can just copy the content from here and apply. The second file I have is the secret. So basically this is how Crossplane is going to communicate with your Shipa API in your Shipa Cloud account. Again, you first have to create an account under apps.shipa.cloud. And then from there, you can download Shipa CLI and you can run Shipa token show, for example. This command is going to give you the token that you can use basically here. You just have to replace the content here with your actual token and apply this file. Great, the secret is created. And last but not least is to configure that provider. I already have also this file, and you're basically telling Crossplane to use that as a secret to communicate with the Shipa API. Awesome, it says it's created. If we just get pods again, I already have my Shipa provider running. Now, the next step is I'm gonna be installing Argo. I'm gonna be using the instructions available in their website. I'm gonna be doing a very basic install. I'm gonna be installing, create the namespace for Argo. Running the install. So basically copy and paste right now, right? Couldn't be easier. Policies are gonna be incredibly easy as well. You'll see it. Great, that is done. I already have the Argo CLI, so I don't need to install. If you don't have it, do it. And then I'm gonna expose my Argo service so I can access the dashboard later. It says it's patched. Then Argo, here the documentation teaches you how to actually log into Argo and change your password. I'm gonna do that in a second. If I do get services, I have to wait for my load balancer IP to be provisioned. So GK, it's usually pretty good, pretty fast with that. Let's wait a little bit. Done. My load balancer IP is provisioned right here. Don't worry about trying to hit the IP. By the time you watch this video, the cluster is long gone. So I can get my secret now. Don't worry about copying my secret. This is going to be long gone as well. But we can log into Argo now. We're using Argo login and the IP, my load balancer IP. It's insecure. I'm not going to do anything related to that right now. And it's going to be admin, I believe. And the password is the password that Argo just gave me. Perfect. I'm just gonna update the password just to something that I can remember later. So the command is ArgoCD account update password, my current ridiculously hard password, and my new password, which is my ridiculously easy password. Awesome, changed. If I try accessing this IP right here, I can probably see my Argo dashboard. Awesome. So control cluster is created. Let's dig now into the policies and the structure around Git. All right, as a quick refresher, we're gonna have three policies. One called development, staging, and another one called production. We already installed our control cluster, and we're gonna be defining these three policies, and we're gonna be binding these three policies to two different clusters, right? I'm not gonna be installing Argo on each cluster. I'm just gonna be using my control cluster, and because I have Shipa in that control cluster, Shipa is going to be taking care of coordinating everything across the multiple clusters, which facilitates our maintenance later, right? So let's do that. Now here, I already have a Git repo. Right now it's empty. There's nothing in here. It's called GitOps policy in this case. If I go back to my terminal, I have my GitOps policy demo in here, and I have created this structure, right? One directory called clusters and another directory called policies. And if I go into policies, I have development, staging, and production folders, right? I just separated into folders so my policies can go into the different folders. Feel free to change it. Nothing is written in stone. If I go into development, there is nothing right here. Let me create a development policy. Let's say this policy, you can find an example of a policy or a complete example of a policy also under learn.shipa.io, and then Crossplane, and then you have framework management, which is your policy frameworks. Here you can find a very detailed policy with all the options that you have. You're gonna see that I'm not defining ingress controller specific stuff. I'm not defining anything related to my cluster API or my cluster provider. I don't know how to do node selectors on Kubernetes, or I don't need to write extensive rules just to be able to define a container policy, right? Saying my developers can only pull from certain repositories. I'm defining it in very English plain version in here. I'm just gonna copy this entire example, and I'm gonna call it development.yaml. I'm gonna paste it here. Let's make this a lot simpler, right? Let's remove all this here. And again, you can find detailed information for each of these fields directly here, explaining in detail. I just want to make this a development policy. So we can see it very easy. Allow all for my ingress and my egress. I won't define anything for container policy, so my developers can pull images and deploy using this policy from any registry. I'm gonna disable scan, so I don't need this. I'm not gonna be doing any application discovery. I don't want to set any controls around domains that they can use. I don't want auto scale. Again, this is a development policy, right? Who cares about that stuff? I'm not going to be doing node selectors because it's just a single cluster. I'm going to set some resource plans. So just controlling how much resources the applications deployed by my developers later using this policy can consume, just so I keep control of my cluster resources. I don't need to mention router, nginx. If you don't mention router, Shipa automatically assume nginx. And Shipa is going to install nginx in that cluster, the controller, and will set up everything. So you don't need to do anything. That's not going to be my default. It's Kubernetes by default. It's not public. And this, let me just, I'll just this provision your Kubernetes. Done. Let me see. What's a plan? What's an existing plan that we have that we can use? There's one called Shipa plan, which has no limits. Exactly what developers like. No limits. Great. So that's my development policy, right? So what I'm defining here is it's a policy for Kubernetes. Every application deployed using this policy should use my Shipa plan, which is an unlimited memory for CPU and memory, for example, and you can see that here. This is my Shipa dashboard, by the way. Very pretty. I'm saying there should be no security scan, so any vulnerability, just go through. And I'm saying set allow all and allow all for both ingress and egress, and allow users to later change that. Awesome. Now I'm gonna go into my staging. I'm gonna do the same thing. Create this policy, staging.yaml. Here, let's say I'm gonna say I'm gonna say deny all for ingress. Oops, deny all and allow all for egress. I'm still gonna not enable security scan, so anything can go through. No app discovery. Maybe some domain policies. So anything developers later, that means that when developers are deploying applications, they can only add CNAMEs to their applications that end with .shipa.io. If there's someone trying to do some funny thing at an app1.google.com, it won't work. They won't allow. This is a staging, so I don't need this. I'm gonna be defining another plan here. So let's see another one that I have. Maybe staging plan. Staging plan, right? I'm gonna keep Kubernetes. It's not public. I don't need engine. I just want Shipa to use nginx. That's the default. Let's just change it to call it CP staging. So this is going to be the name of the policy. So what I'm doing is I'm creating a policy called CP staging. It's using the staging plan, which limits the applications deployed later by the developers using this policy to consume maximum of this amount of memory and this CPU. And I'm saying that security scan is not needed. I'm saying domain. This can only be the CNAME added to the apps by the developers later. and I want to deny all for ingress and allow all for egress for my applications. All right, so I have this created, and last but not least is production. I'm gonna create a production YAML, and I'm gonna do the same. Here, I'm gonna set container policy. So I'm saying that later on, developers that use this policy to deploy applications, they can only pull images from these two registries. I'm gonna say I want deny all by default. For egress, it can be very detailed here. And I want every application also to have deny all, for example, for ingress. So every application using production policies should get deny all and deny all for both ingress and egress. Me as a DevOps engineer, I don't care how Istio, how Nginx does that. I'm just defining it in plain English. I'm gonna not disable scan. I'm gonna say it's false. Scans should run, and I only want to allow these two vulnerabilities. Anything other than that, block my deployment, right? Because it's production. I don't want to do auto discovery. These are my CNAMEs. I'll just keep on doing Shipa.io. So if a developer deploys an app and tries to pass another CNAME that is not Shipa.io using policy production, it won't work. I'm gonna set autoscaler because it's production, so I want to make sure that applications can behave as expected. I'm gonna set the number minimum amount of replicas to 2 in this case, and I'm gonna set it to 5 to maximum. And here's my target CPU. But I want to enable application owners later to go into their specific apps later and customize the autoscale policy, right? So you're setting defaults, but you're allowing the application owner later post deployment to change or customize this. And it's the same thing for your network policy. For example, you have here disable app policies. I'm setting to false. So my developers or the application owners, they can later customize their their network policies for specific apps. But by default, every application deployed using this policy will get these rules, right? I'm not using node selectors because I only have one node, I think. And my plan or resource limits, I'm gonna use one called production plan or prod plan. So this is the amount of memory and the CPU that they get by default, or the apps get. Prod plan. This I don't need, this I don't need, this I don't need. And I'm gonna call this CP prod. Awesome. So we have defined 3 policies: dev, staging, and production. All different, right? You don't need to know Kubernetes to do that. It's easy, right? And it's scalable because at this point, I'm not defining anything for 119, 121, or GKE versus AKS. I'm defining policies, right? Awesome. I save this, and I can probably push this. Let's see. Let's see. Where's my Git? Where's my Git? Oh, here it is. I'll do Git. Is it right? Yeah, Git init. Git add. Git commit. Yeah, I'm just kind of following everything here. Setting it to main. Remote. And pushed. If we do this, I see my policies here, and I see my 3 folders, development, everything that we did, right? So our policy definitions are now in Git. So what we got to do now is configure Argo now to monitor these policies and apply these policies to Shipa. So it can create these policies and then we can connect these policies to our clusters. If we go to Argo, very quick, we can do repositories. If you click on settings here, and then you can connect using your SSH. I'm gonna do policies control. It's a default project. My repo URL, if I'm using SSH, for example, it's this one. I'll enter my private key data. And so I'll do that here and we'll come back in a second. So we don't need to see my private data. All right, so I entered my key now, or my ID, my key, whatever. And I have my Git repo already connected to my Argo. Let's now create our policies, right? So if we go to Shipa dashboard and we click on frameworks, which is where your policy frameworks are located, we can see that there is nothing there right now. Of course, you can create a policy directly from here and you get the beautiful interface, but the idea and the goal is to have everything directly from Git, right? So just to see, we're starting from a clean slate. If we go to Argo and we go on manage applications, we can create a new application. Of course, you can create this as a definition, also store in Git, but the purpose of this video is to show you how to create easy to define policies, scalable across multiple clusters. So I'll just say dev policy, right? I'll just create this with this name. I'll say it's a default. I'll say automatic, prune resources. So if I delete it here, it deletes it there. It self-heals, all this cool stuff that Argo does. I'm setting my Git repo and I'm saying development, for example, what's the path, right? For development, say this is the path for development. And the cluster is going to be the local cluster, because Argo will communicate with Shipa and Shipa will apply the policies and connect these policies to the other clusters we have, right? So we don't need to get into the funky business of how do you install Argo across multiple clusters, how does Argo manages that, and what ingress controllers and we have and on each cluster, in cluster, my friend, and using English policies. So I'm just gonna say this, and so dev policy, default project, syncing automatically, passing our Git repo, and saying this is a development, right? If I do create, it says it's creating, it's syncing, and it says it is synced. So we see here dev policy, it's CP dev. And if we go to our dashboard and update, here's our CP dev. We created our dev policy, right? Out of our definition. Look how easy this is. This. If it doesn't cut my fingers. This, right? So much better, so much easier. Nice. So let's do quickly production and staging. If we go to Shipa and we refresh, it is okay. It is here. So now all our policies are here. Dev, staging, and production, right? And if anyone asks you what type of policies you get from production, you can see it directly here. You can update, for example, and you get, here's the resource consumption, Mr. Manager, that you get. Here's the registry controls, DevSecOps dude, that you get, or do that. Here are the network policies that you get. So you can quickly go back to your team. Awesome. So we've done now the process of creating the policies, right? We have the policies created. It's easy. It's beautiful. See, that is an easy policy. Not tied to your underlying cluster. You can apply anywhere. Now let's bind these policies somewhere. We created these policies on Shipa, right? But we can see that these policies are not bound to any cluster. Let's do that. we can create a cluster definition file. You have an example here, for example, on cluster management on how to do that. Let me copy this file, go here. Let me just do this directly from here, right? CD clusters, and I'm gonna do VI AKS cluster, maybe I'll call it. I'll put the definition here. Let's do this. We're gonna be calling this one AKS staging dev, right? AKS staging dev, that's the name of our cluster. Now, what this is gonna ask you for is basically entering your cluster API, the CA cert, and a token for Shipa. We don't need this. Our clusters are empty. There is nothing in both my AKS cluster and my GKE cluster, right? These are the names of the frameworks or the policies that I want to connect to these clusters. So since we're starting with our AKS cluster, we're going to be connecting two policies. From the beginning, we said we want to do dev and staging. Sorry, so CP dev and CP staging. Let's update it. So CP dev and CP staging. Now it's going to ask me for my endpoint for my application. I have my cluster here. Let me connect to my cluster. Let me open a new thing. Of course, you can do this all automatically, right? Using Crossplane, for example. So if we just remove this, I'll do AZ get credentials. What's my cluster name? My cluster name is app cluster AKS. Okay, so if we do this, kubectl get nodes now, I can see my AKS node, and if I do get namespace, you can see I have nothing in there, right? It's just my kind of regular cluster empty. If I do this files, right? I need three pieces of information here. One is my address, and I need my CA cert, and I need my token in here. The token and the CA cert are it's an account that you create for Shipa, so Shipa can connect to your cluster and perform the actions related to the app, the policies, and everything. You can find details on how to create the service accounts right here under Kubernetes clusters and then connecting cluster. It's gonna teach you how to get the API endpoint and create the service account and so on. I have a small script here that I can run, that I usually run. I'll share that in the video description. But basically it creates a service account, gives me the address, gives me the token. So I'll just update this here. All right, so now with my token and my certificate entered here, again, don't bother copying this. So what I'm saying is this is the cluster name, right? This is the API for my cluster and the certificate and the token for the accounts we've created using Shipa. For Shipa, I mean, sorry. And those are the two policies that I want to connect to that cluster. Great. I created one, and I'm creating another one called GKE cluster.yaml, or even VI GKE cluster.yaml. Great. All right, so I've entered here my GKE cluster info. Again, I'm doing this manually, but do that from your Git, please. Crossplane, don't do that manually. But I enter the name, GKE cluster, the address, the certificate, and the token. I don't need this because I don't have an existing ingress controller in that cluster. I want Shipa to automatically install Nginx and configure it Nginx for me. And the name of the framework that I want, or the policy that I want to connect to this cluster, is Let's see, it's cp prod. Cp prod. Again, you can automate this as an environment variable. Do a bunch of stuff, right? Cool stuff. So if we do git add, git commit, add cluster, and then git push, update, I see clusters, right? So now we have two definitions here in Git. We have the policies definitions and we have the clusters definitions. And the cluster definitions points where these which policies should be connected to which cluster. Let's go to Argo. And Argo, we can create a new app. We can say here it's clusters. Default, same thing as before. But now, as part of my path, I'm gonna say clusters. Done, and create. All right, it says it's created. If we go to our Shipa dashboard and we go to events, we're gonna be seeing two events here, right? One, as soon as the first one finishes, you're gonna see the second one starting, which is creating the GKE cluster and then your AKS clusters. What Shipa is doing here, Shipa is connecting to your cluster and then connecting that policy, creating all the services and running everything directly from there. This takes about 2 minutes. We see here GKE cluster is coming up already. If we do kubectl get namespace, for example, we see two things. One is our Shipa namespace, and the other one is our Shipa cp prod namespace, right? If we go to Argo, clusters, we can see we have the two here. And if we go to, see it's creating our AKS cluster. It's gonna take another 2 minutes as well. The events for it's still running. If we do here, for example, let's just do this to be easier. And I do get namespace for this one for my Azure cluster. I can see here my staging and my dev policies, right? So, okay, so quick recap while this thing's still finishing. We've created 3 policies, dev, QA, and production. Our policies are very easy to understand, no complex, no very lengthy policies, no cluster infrastructure here mentioned, no ingress, no components, no nothing. Very plain English application level policies, right? Created 3 policies. We've created the definitions for 2 clusters that we wanted these policies connected to, one in GKE and one in AKS. Policies are distributed across these 2 clusters, and I can see those 2 cluster information here. I can see my policies here. I can see all the details of my policy, and you can see that the policies I define here doesn't really matter. Later on, if I want to move these policies to another cluster or copy and paste these policies to other clusters, other versions, it's scalable, my friend. You do whatever you need. And later on, which is another video, we can deploy an application. And you're going to see that your developer, they won't see any more clusters. They don't need to understand all the underlying infrastructure. All you give them is actually a policy. So when they deploy their applications, they are just going to go through the policy, and based on the policy, Shipa knows where to deploy these applications. I hope that was helpful, and I hope that helped you see an option on how you can actually deploy and deliver policies in a scalable way, basically delivering this. Thank you for taking the time.